Hi, Assalamualaikum. My name is Nur Ifaiza. So right now I will present to you about CHM 131 presentation video with a subtopic called the atomic history. So without further introduction, let's check out the presentation video. So right here, right now we have an atomic model or a diagram. So what is an atom? So atom is the smallest part or the basic unit of matter. So as you can see in the diagram here, we can see that in atom we have nucleus, which is at the central part, and then we have an electron that can be one, two or more electrons surrounded around the nucleus. So in the nucleus we have proton and neutron, which is a positive charge, and then we have the electron that was surrounded the nucleus, which is a negative charge. So where does this diagram or model come from? So now let's check out the early idea of atom, which is come from the Democritus atom. This is the example of atomic model or the diagram of Democritus atom. So Democritus is the first philosopher that used the term of atom, which came from the Greek word atomos, means indivisible or unbreakable. So in his theory, the atoms were small to be seen, and then the atoms were solid, and each of them have different size, shapes and weight. So there is a void or empty space between the atom. So from the Democritus atom, there is a history of atom that developed from there, which start from the John Dalton in 1803 with his atomic model called solid sphere model. Next, we have in 1904, we have J.J. Thomson with his atomic model called plum pudding model. And then in 1911, we have Ernest Rutherford with his nuclear model or planetary model. Next, we have Niels Bohr with his planetary model in 1930. And lastly, we have Erwin Schrödinger with his quantum model in 1926. So first, let's check out the John Dalton solid sphere model. The John Dalton's theory. So this is the example of the solid sphere model or the atomic model. So John Dalton is the first one to develop more scientific definition of atom in modern atomic model by using the Democritus theory. So his theory is pretty similar to the Democritus theory, so which is all matter consists of indivisible atom. Atom cannot be destroyed or subdivided. So when there is a chemical reaction, the atoms will combine to make a compound. And then elements can be classified by the atom's weight. Next, we have J.J. Thomson theory. So J.J. Thomson is the one that discovered the electron in the atom using cathode ray tube technology. So when he carried out his experiment, he found that the charge deflects away from the negative charge of the metal plate, but attracted to the positive charge, which means that the charge were negative. And then the particle were 2000 lighter than the hydrogen. And he found that the atom is not indivisible, but have small constituent parts or small parts. So this is the example of the cathode ray tube that he is using for carrying out the experiment. So from the experiment, he created this atomic model called plum pudding model. So in his theory, each atom were filled with fluid, which is a positive charge. As you can see in the diagram here, this is the fluid. And then corpuscle, or right now we call it as electrons, are the negative charge that hanging around the fluid. So this model called a plum pudding, as he described the positive charge, which is the fluid, is the sticky part in the pudding, while the negative charge resembles the plum. So next we have Ernest Rutherford theory. So this is the example of his atomic model called the nuclear or planetary model. So throughout his gold foil experiment, which involved firing alpha, which is a positive charge, to the gold foil, he found that most particles did not deflect at all, but some will deflect all the way back at one at a time, every now and then. So he found that there was a positive charge at the central, which called a nucleus. So as you can see, like right here in the diagram, so the positive charge right here, the central is a nucleus. So this is the example of the gold foil experiment. So next we will go to the Niels Bohr theory. So this is the example of his atomic model, which is called the planetary model, which is a development to the Ernest Rutherford planetary model. So right here we can see that there is an orbit. In different orbit we have different kind of energy and shell. So Niels Bohr agreed with Ernest Rutherford's theory. So using his knowledge, he was able to perfect the theory, like in the diagram here. So in his theory, electrons move around in the nucleus in orbit in a set of energies and size, like the solar system, like in the solar system. So the lower the energy, the lower the orbit will be. And if the energy was filled, a new energy will take it. So lastly, we will check out the Schrödinger theory. So this is the example of his atomic model called quantum model. So this one we have the blue dots called electron cloud or wave around the nucleus. This is the example of cloud model. We have nucleus at the center, we have the orbitals. So Ernst Schrödinger used the Heisenberg sensitivity principle to create his model, like this in the example. So in his theory, electrons did not exactly orbit around the nucleus. Instead, they behave like a wave. So like the first diagram here. So it is unlikely to predict where the location of the electrons will be, but we can view the electron cloud, okay, here, which is a region that we can find the electrons in it, to accurately find where the location of electrons. So next is the conclusion. So the first one, the John Dalton solid sphere model is not accurate, as it is proof that the atom is not indivisible. And that the J.J. Thomson plum pudding was also not accurate, as there is no explanation about the latter experiment and there is no nucleus in his atom. The Ernest Rutherford nuclear or planetary model was also not accurate, as there is no explanation why the electrons remain around the nucleus in orbit. The Niels Bohr atomic model, also not accurate, as electrons does not travel in orbit or a specific path. So lastly, the quantum model by Ernst Schrödinger was widely accepted, as it is the most accurate atomic model until now. So this is the references that I used for helping my presentation video. Okay, here I use the website, which is called A Brief History of Atomic Theory and the History of Atoms. So that is all from me. Thank you for hearing me out. See you next time. Bye.